Hi, in this video, I will be showing you problem number 11 of chapter 4 section 8 from the practice exam. Use Newton's method to approximate the given number correct to 8 decimal places. Fourth root of 72. So we will call this number as x, which is fourth root of 72. So if you take the fourth to power on both sides, so it will become x to the power 4 equal to fourth root of fourth power, that will be 72. So it is x to the power 4 minus 72 equal to 0. So if we can call f of x as x to the power 4 minus 72, we are actually finding out the fourth root of 72 actually means finding the root of this equation fx equal to 0. X to the power 4 minus 72 equal to 0. So we are finding pretty much the root of this equation. In the earlier problem, we were given the first approximation to the equation, but the root. But in this problem, we are not given the first approximation, but we can kind of guess what the first approximation is. If you look at this, is not exactly, we cannot find out the fourth root of 72 exactly. But if you look at the number 81, which is close to 72, fourth root of 81 is going to be 3. And this 81 is fairly close to 72. So we can consider x1 can be 3, which is our first approximation to the root. Then the formula for Newton's method xn plus 1, the n plus first approximation is nth approximation minus functional value at the nth approximation, and then the derivative at the nth approximation. This is the formula we will be using. As we did the previous problem with the help of the graphing calculator, we will use the same technique to use same graphing calculator to do this problem in a quicker way. So we notice that in y1, you have to plug in the function f of x, which is x to the power 4 minus 72. And then in y2 line, you plug in its derivative of the previous line, f of x. So x to the power 4 minus 72 derivative is 4x cubed. On the third line, y3, you input the function x minus y1 over y2. y1 here stands for f of x, y2 here stands for f prime x. Then you go to the home screen. You know how to get that y1 and y2. The y1 and y2 can be done by clicking VAR and then using yvar and choosing the function mode, and then 1 and 2 for y1 and y2. Then you go to the home screen, and then we have to compute y3. At the first approximation, we have chosen the first approximation as 3. So we have to compute y3 at 3. So to get to y3, use the VAR button, then yvar by using the right arrow. Choose the function, but we don't want y1, but we want y3. y3 is in 3. So menu 3, so that will bring up y3. Then plug in your first approximation, which is 3. Then close the parenthesis, hit enter. So what you get here, which is 2.91666667, is the second approximation to the root. Now, in order to get the third approximation, we have to input this value into the function, into y3. So go to VAR and then use the right arrow to pick yvars. Then choose the function by hitting 1. But we don't want y1, we want y3. So hit 3. Then you input the answer from the previous. Instead of plugging in 2.9166 as a big number, you input the answer from the previous line. In order to pick the answer, you go to the second and the negative button in your calculator. That will bring up the answer from the previous line. Then close the parentheses. So now you are evaluating the function y3 at the second approximation. What you are going to get is the third approximation. So you continue to do this. Now you can hit the enter button right away, because the answer is going to now take the line answer from the previous line. Now you hit the enter button. This gives one value, which is, so the first line here is x2, second line is x3, third line is x4, then hit one more. Okay, so you notice here fourth and the fifth are agreeing on 8 decimal places. So that is going to be your actual root. So which is 2.91. So in this case, it's going to be 2.91295063. So the first line is the second approximation, third one is the third approximation, and then the third line and the fourth line is x4 and x5, fourth approximation and the fifth approximation. They agree on 8 decimal places, so that is our actual root. So x4 and x5 are approximately equal to each other. They agree on 8 decimal places. So you would say that this is your approximation approximated to 8 decimal places as given in the problem. Hope this video helped.